Alrighty, so chapter 10 is on function operations. There's 3 fairly quick sections to this chapter that we're going to look at. So the first one is function notation and the sum and difference, and then we'll look at the product and quotient of function notation. So first of all, we need to know what a function is. So if we think of a function, what we're thinking is, or what it means, is that for every possible input value, if you think of putting it into an equation, there is one output value. So when you have one input value, there is one output value. And that one output value is the key. That's what makes it a function. So if I think of my x and y chart when I'm doing my graphing, my x is my input, that's the value I'm putting in and then solving, and my y value when I solve is my output value. So if I had 0, 1, 2, 5, 4, 9, 6, 13, 8, 17, and 10, 21. So if I look at my input and my output values, every single time here, to go from 1 to 5, I went up 4. 5 to 9, 4. 9 to 13, these were all add 4, or plus 4. If I look at my input value, what I'm doing is I'm saying, okay, what did I have to do to that in order to increase that output value? So when I started at 0, I had a value of 1. When I input a 2, my value went up to 5, so it was an increase of 4. When I input a 4, I ended up at 9. So if you think of 2 and 5, the relationship is there. If you double 2, you get 4. You add 1, you get 5. For 4, if you double 4, you get 8. You add 1, you get 9. So what's happening here is I'm starting at the value of 1. So my function can be defined by the equation. In whichever spot you put it doesn't matter. It would be y is equal to, I'm starting at 1, and it's a positive 1. And then I'm taking my, whatever the number is that I'm putting in there, and I'm doubling it. So that would mean 2x. So by definition, a function is a relation. And from now on, I just use fn as my function shorthand. So a function is a relation where for every x value, there is only one y value. So if I take a look at this graph here, which graph is a function? Every x value that I have here, so I had a negative 4, I only had one y value. There's no other y value that matches up with negative 4. If I look at this one, it's a negative 2. There's a y value here at negative 2, but there is no other one. Over here at 3, is that 3? 1, 2, 3, right? There's a y value down here, and there's a y value down there. And there was one for the x. This was a function up until I got that x is equal to 3 value, because at that point I had two y values. So this is not a function. If I take a look at this graph, so at -4, there was only one y value. At -1, there's only one y. At 1, there's only one y value. And at 4, there's only one value. So, oh, and then there's one over here at, I'm not sure if that's 10 or 11, but whatever that value is, there is only one y value. So this one is a function. And that's because for every x value, there's only one y value on this graph. We can do a thing, and we would have done it, I can't remember if that was in Pre-Calc 20 or in Foundations 20, the vertical line test. If you can draw a vertical line and it only cuts through a graph in one place, then you have a function. So something like this, a graph that would look like this, a parabola, is a function. But if we do this to our parabola, this is no longer a function because my vertical line test cut it in two places. So the next thing says, which relations below represent a function? So if I take a look here, for every x value, I can only have one y value. So I have a 2, 6, 3, 9, 6, 21, 8, 43. So my x values, none of them repeated, and none of my y values repeated. So this is a function. If I look at the next one, 5, 3, 7, 12, 2, 6, 7, -3, and 1, -3. Well, 5, 3, and 1, 3, the y value repeated. Sorry, not the y value. For this, I looked at the wrong example here. That one wouldn't matter if you were to draw that one, because my x values were different, but my y values were the same. That's okay. But if I look at this one, for my x value of 7, I had a 12. But also for my x value here of 7, I had a value of -3. So both 12 and -3 had an x value of 7. So if you were thinking, if you plotted this at 7, I would have 7, 12 would be up here, and 7, -3 would be right there. So they're both in line with the 7. So if your x value repeats itself, then you can't have a function. So in function notation, y is equal to 2x plus 1 is considered to be an equation. It's a relation, but if we want to put it as a function notation, then what that means is we use the f of x or whatever letter. F of x just is usually the most common one. fx is function notation. So fx is equal to 2x plus 1 is how we would rewrite y is equal to 2x plus 1 in function notation. I used fx, but you can use, like I said, any letter. It could be g of x, you could use, hx, you could use whatever letter you want. You just wouldn't want to use an xx, that's kind of confusing, or a yx can get confusing too. Our most common ones that you're going to see are going to be f, g, and h. So if an equation or a question says, what is a function at 3? So what they're saying is, what happens when you substitute 3 into that equation? So I go 2 times 3 plus 1, so this is 7. Next question says, if f of x is equal to x squared minus 2x plus 5, find the function of 2. So it's saying what would be the y value, or what is the function of this graph when your x value is a 2. So what that means is, wherever there's an x, I'm going to substitute in a 2. So this becomes 2 squared minus 2 times 2 plus 5. So this is 4 minus 4 plus 5. So my answer is 5. So the function at 2 is equal to 5. Another way to write this would be that 2, 5 is your coordinate. Okay, so just a couple more examples of finding what the value of a function is. If fx is equal to x cubed minus x plus 1, what is the function at negative 4? So this would be negative 4 cubed minus negative 4 plus 1. So negative 4 cubed is negative 64 plus 4 plus 1. That equals negative 59. What is the function at 0.5? So I substitute 0.5 wherever there was an x. So 0.5 cubed minus 0.5 plus 1. So when you put that in your calculator, you get 0.625. Oop, I went the wrong arrow over there. Okay. Now this one they're substituting instead of a value, they're substituting in a binomial. So if you're given the function is x squared minus 1, find the function of x plus 2. So all that is saying then is wherever there's an x, I'm going to substitute in x plus 2. So this becomes x plus 2 squared minus 1. So x plus 2 squared using my shortcut. This is x squared. X times 2 gives me a 4x. Square my last term, so that's a 4 minus 1. So this is equal to x squared plus 4x plus 3. Okay, if my function, I want to find the function of 2 square root x minus 1. So 2 square root x minus 1 all squared minus 1. So squaring this, remember whenever you square a binomial, you have to have a trinomial. So 2 times square root of x all squared is going to be 4. Square root of x squared is just x. My middle term is multiplying everything together. So 2 square root x minus 1 is negative 2 square root x times 2 is negative 4 square root x. And then I square my last term, negative 1 squared is positive 1, and then I have my minus 1. So this is 4x minus 4 square root x. Okay, the next part here says the function notation can be used even when there is no known equation relating to the variables. So you can pick out values from an equation when you're not actually given the equation, but you're given the graph of it. So this one says find the function is 3. So find the function of 3. So what this is saying is, what is the value of y when x is equal to 3? So I have a 3 for my x. I want to know what my y is. So when I take a look at my graph, I find x equal to 3. So 1, 2, 3 is here on the graph. That's going to coincide with that right there. So that would be negative 5. So to write this in function notation, the function of 3 is equal to negative 5. So if I use this graph to find what is function of negative 8. So negative 8 on my graph here is negative 5, 6, 7, 8. It's right here. So I look on the graph, where does that meet up? So that's right there. So that is at 1, 2, 3. So function of negative 8 is equal to 3. So it's just as simple as picking out the coordinates on that graph. Okay. So now we worked a little bit about functions. Now we're going to use some properties with these functions. We're going to find the sum and difference of functions. So it says you can form new functions by performing operations. For the sum function, when you can have a new function, so h of x can equal to f of x plus g of x, or another way you could write that is you would take f plus g of x, or f plus g of x. So we're finding the functions when we add them. For the difference function, if you have one function minus another, then what you can do is just subtract the functions. So what does that mean in math? It says consider the function f of x is equal to negative 4x minus 3 and gx is equal to 2x squared. Determine the equation of the function hx is equal to f plus gx. So what we're going to do there, in A, it's asking us, what is my function if I were to add the two functions together? So what we do then is we take each of these functions separately. So I'm working from this idea and going back up to that one. So this is the same as saying the function of x plus the g of x. So if I substitute, f of x is equal to negative 4x minus 3, and it's always a good idea to put those in brackets, especially when you get to the difference one where that minus sign in here is going to affect your answer. So this is plus g of x is equal to 2x squared. So this is equal to 2x squared minus 4x minus 3. So that would be my new function. B part says, sketch the graphs of fx, gx, and hx on the same set of coordinates. So in order to graph these, I have to know some values to plot in here. So I can do this in kind of a modified t-chart, because I'm going to do my graph for my input being x, and I'm going to put that into my fx function, I'm going to put it into my gx function, and I'm going to put that into my hx function. So if I use negative 1, 0, 1, and 2 as my input values, if I do that in f of x, so remember that is negative 4x minus 3. So that is negative 4 times negative 1 is positive 4 minus 3, leaves me with 1. If I substitute a 0 in there, I'm left with negative 3. If I substitute a 1, that's a negative 7. If I substitute a 2, oops, that's a negative 11. So g of x, and g of x was equal to 2x squared. So x squared, if I substitute a negative 1, that's positive 1, so that's a 2. If I substitute a 0, it's just 0. 1 is 2, and 2 will give me 8. hx, so remember hx then is this function here, which if I take a look at my equation was just my gx, 2x squared, and then minus 4x minus 3. Excuse me. So if I add these functions together, 1 and 2 is 3. Negative 3 and 0 is 3. Negative 7 and 2 is negative 5, and negative 11 plus 8 is negative 3. So all I did here was I just added this. I went, this is equal to this. Because the question was saying, what is f of x plus g of x? I could have substituted my values in there, but then I would have to substitute both values in there into, I would have to done negative 4 times negative 1 minus 3 plus 2 times negative 1 squared, which would just give me 3. So the quicker way to do it is just actually add your fx and your gx together. So if I draw this picture, I'm going to draw it in black. Oops, ooh, that's not a very straight line. We'll pretend it is. So here's x, whoops, there's y, and here's x. So f of x is I know it's a line. Let's do that one in blue. So it was at -1 and 1. I have to go all the way to -11. Well, this will be a little tight, but close enough. Okay, so -1, 1 puts me here. 0 and -3. 1 and -7. And finally 2 and -11. Well, I put my -11 there, so 8, 9, 10, 11. So that puts me about right there. So if I draw this relation, it's a straightish line. Pretend this is a straight line. So that is f of x. G of x then, my value is at -1 and 2. Zero and 0. 1 and -7. Sorry, not 1 and -7. 1 and 2. And then it was 2 and 8. So that's going to be way up here. So my graph is a parabola going kind of like that. So that's my g of x. So my hx was at -1 and 3. -1, 3, 0 and -3. 1 and -5. And then 2 and -3. So it starts to go back up. Oops, pretend that actually went through that point. So this would be my hx graph. Okay. The C part then says, state the domain and range of hx. So to find the domain and range of hx, I have to find the domain and range of each one of my graphs or each one of my functions that I put together, and then see what they have in common. So for my f of x graph, I could use any number. So my graph is going like this. So I could go x is an element of real numbers. I can use any, it's the whole number line, right? My gx graph for my domain, I can use any value in there again. And this is a nice easy one because it works that way. So x is also an element of real numbers for this. Because I could go any positive x value and any positive or in any negative x value. My hx graph, I could do the same thing. I could have gone any positive and any negative value. So they all have the same thing in common. So my domain for the whole, my new function hx would be x is an element of real numbers, and it just so happens for this one, it works out the same. But my range, if I take a look at my range, I have to take a look at what is the smallest or the largest value in this case, or it can be the largest value. But because of this graph is a regular parabola, then I know I have a minimum point. So and that occurs right here. So in order for it to be the domain for hx, I have to take a look at that graph there, my red graph, and I can see that my domain is going to be, or my range is y has to be greater than or equal to -5. I only had one question on that page. Oh good, it's on the next page. Okay. So example 2 says, consider the function fx is equal to square root x minus 1 and gx is equal to x minus 2. Determine the equation of the function hx is equal to f minus g of x. So this time I'm going to subtract my functions. What color am I? Blue? Okay. So what I want to find out is what happens if I go fx, the function of x, minus the g of x. So if I substitute this in here, I have square root of x minus 1 minus x minus 2. So this is where putting them in brackets is helpful because you don't want to forget to distribute that minus sign. So this would be square root of x minus 1 minus x plus 2. Okay, so the same thing, sketch the graph for these. And this one is asking you to sketch for all three of them. You could, if it just said to sketch the graph of the new relation, then you could do, or the new function, you could just do this graph right here. So here's my x, my f of x, g of x, and my h of x. So I'm going to use my values 0, 1, 2, 5, and 10. Why didn't I use negative values for this? Well, the reason is right in here, because I've got this square root, I can't have a negative value in there. So what happens when I substitute a 0 into f of x? So remember, this is my, this is my fx relation. So if I substitute a 0 into there, this is undefined because I have a square root of a -1. If I substitute a 1, it's a 0, 2 is 1, 5, so 5 minus 1 is 4, so that's a 2, square root of that is 2, 10 minus 1 is 9, square root of that is 3. So you can see why I specifically picked those values, because they worked out to be perfect squares. What about the g of x? So g of x is this relation. So if I substitute a 0 into there, 0 minus 2 is -2, 1 minus 2 is -1, 2 minus 2 is 0, 5 minus 2 is 3, 10 minus, 10 minus 2 is 8. I was going to put a 3 in there. So now if I do h of x, so remember hx is equal to fx minus gx. So if I look at my first one, I have an undefined -2. Well, I can't do anything, so that's undefined. Whoops, I'm going to change that color. So this is my hx relation. 0 minus -1 is a positive 1. 1 minus 0 is 1. 2 minus 3 is -1. 3 minus 8 is -5. So those are the values that I would use to graph these. Okay, so drawing my picture of this. Oh, why didn't that change to black? Oops, that's a little bit big. Must be a kink in my board there. Okay, so if I'm graphing f of x, that's my purple one. What do I need for values? 0, 1, 2, and 3 x's I need. Okay, so I have my arrows at the end of this, so I'm drawing this properly. So my first 0 was undefined, so I can't draw that one. 1 and 0 puts me there. 2 and 1, 5 and 2, and that should be going in a straight line. It's a little bit on the wonky side, isn't it? This dot here is a little bit high. I'm going to make it thicker. Okay. Where was I? 5, 2, and then 10 and 3. So it's a straight line. Well, I guess it's not really a super straight line. Oh. It's not a straight line. I shouldn't have said that. It's this part of, because it's the square root of a parabola, so it's a half parabola turned on its side. I was looking at the wrong one on my diagram here. So g of x graph. G of x is just that x minus 2. That's my straight line. So at 0, I was negative 2. At 1, I was negative 1. At 2, I was 0. At 5, I was 2. At 10, I was 3. Nope, sorry, 10, I was... Did I do that right? Nope. But that should have been a 5. Oh, this one here is the wrong dot. 1, 2, 3, 4, 5, 1, 2, 3 is right there. I've got a little bit high. And then the last one was at 10 and 8. So 10 and 8 is up here. So this graph would be a straight line, and it would continue even though that's all those are the only values I've used. It would look like that. So this is the g of x graph. I didn't label my fx. So hx then. At 0, it was undefined. At 1, it was at 1. So 1, 1 is there. At 2, it was 1. 1, 2, it was 1. At 5, it was negative 1. So 2, 3, 4, 5, negative 1. And then at 10, it was negative 5. So 10 and negative 5, that's 2, 3, 4, 5. So it's about like that. So even though it's a little bit hard to tell, if we use points in between, this would actually curve up and then come back down through there like that. So looking just at the C part here, this is h of x. Oops. Looking just at C, it says state the domain of h of x. So I could look just at this graph and find out that my domain for the green graph is just what the stipulations or the regulations are on the x values for the green. Well, on this one, I can't go past that 1. So my domain for h of x, the domain is x is everything greater than or equal to 1. Sometimes what you have to do, though, if you don't draw the graph, is you have to look at your x, or your functions that you put together to get that. So if I were to look at this separately, for the function of x, my domain That's my purple graph here. My domain was started at 1 and went in that direction. So if I were to draw a number line, I would start at 1 here and go in this direction. So in this direction would be positive, and this direction here, it's undefined. My g of x then, if I take a look at that graph, g of x, I could have used everything. So it gives me positive values there, and on to the right of my 0, I would have had negative values. So when I look at this, then I have to say, okay, which parts did they have positives in common? So in this case, well, that 0 should have been over here. This should be 1. That would be 0. So what do they have in common? Everything. Let me use this. To the left of, or to the right of 1. So that's where that x is greater than or equal to 1 comes from. And you'll use that when you're not actually drawing the graphs. You're just supposed to look at the equations. So it says use the graph to approximate the range of h of x. So my range, if I look at this, I'm starting here. I go up a little ways. So from my green, I'm starting here. I go up a bit, and then I come back down. So approximately, my range is in between 1 and 2. So I could say for this one that my range is at about everything greater than or equal to, be less than or equal to. Could be 1.5, could be 1.6, could be a little less. So whatever value you pick, because it says approximate. So even if you put a 1.2. So why is everything approximately smaller than 1.2? Okay. Example 3 says, sketch the graph of it's on there. Of mx is equal to f minus gx, given the graphs of fx and gx. So, let's pretend this purple line is not there, because that is my mx graph. So what you would do is this. So method 1 is to subtract coordinates. So what you would do is you do your x, your f of x, g of x, and then from there you would find your hx. So we'll see if this works out. So for my x, if I were to pick these values that they have the dots on, so they have the dots on -4, -3, -2, -1, 0, and then 1, 2, 3, 4. 1, 2, 3, 4. So on my fx graph, that's kind of the dark blue one, when it was at -4, my y was at -3. When it was at -3, my x is at, or my function, or my y value is at -2. When it was -2, it was -1. -1, it was at 0. 0, it was at 1. 1 is at 2. 2 is at 3. 3 is at 4. And 4 is at 5. Okay, if I look at my red graph here, when x was -4, my y was +1. When it was at -3, it was at 0. -2 is -1. -1 is -2. 0 is -3. Where am I? 0. 1 is -4. 2 is -5. 3 is -6. And 4 is Oops, did I line those up wrong? My eyes are going screwy. -4, 1, -3, 0, -2, -1, -1, -2, 0, and -3, 1 and -4, 2 and -5, 3 and -6, there we go, and 4 and -7. So then, if I subtract my coordinates, if I say my fx minus my gx is equal to my hx, -3 minus 1 is -4. I guess I could use purple for that one, since it's purple. -2 minus 0 is -2. -1 plus 1 is 0. 0 plus 2 is 2. 1 plus 3 is 4. 2 plus 4 is 6. 3 plus 5 is 8. 4 plus 6 is 10. And then 5 plus 7 is 12. So if I check my coordinates on here, these should match up on my purples. So -4 and -4. -4 here, -4. So that one worked. -3 and -2. That one worked. -2 and 0. Where am I? -1 and 2. So you can see these, just the equation or the graph that I left on there, my alignment was a little bit off. So it's, my graph looks like it's off, but it's actually okay. So at 0 then it was 4, and then that's kind of where I quit here, but I could go from 1 to 6 would still work on there, and then I'd be off my graph. So you can see that's one way of doing it. So you find your x and y coordinates for your functions, and then you subtract them. Method 2, and method 2 is easy enough to do when you have just linear functions. It gets a little bit trickier when you have quadratics or something on there, or a square root function or whatever, because then you have to use transformations and your stretches and so on in order to find out what your equation is. So if I determine the equations, what am I doing? So for f of x, I'm looking at, okay, what's my y-intercept? So my b is equal to 1. And then if I pick another point for my slope, I went up 1 over 1, so that's a 1. So my equation for the fx is mx plus b, so that's just going to be x plus 1. For the gx graph, my y-intercept was at -3. Right there, and then if I pick a point, whether I go up or down, so my slope went down 1 and over 1, so it's a -1. So my equation is going to be -x minus 3. So to find my mx, I was subtracting, so that's equal to f of x minus my g of x. So this is x plus 1 minus -x minus 3. So that's equal to x. If I distribute my -x, that's going to be a 2x. 1 plus 3 is 4. So if I check that on my graph here, my purple graph, my y-intercept should have been at 4, and it is. It's right here. And if I try a slope, so to go from my 4 to my next point, I went up 2 over 1, which is my m. So either way works. The equation method way is easier if it's just linear functions that you're working with. Okay, example 4. It says, Reach for the Top is an academic challenge program offered to students across Canada. Suppose the cost of the t-shirts for the program includes $125 in fixed costs and $7.50 per shirt. The shirts are sold for $12 each. So the first part says, write an equation to represent the cost, C, as a function of the number of t-shirts produced, and then the revenue as a function of the number n of t-shirts sold. So for my cost, my function would be C of n, so cost of my number of shirts would be, so it's a base cost of $125 or a fixed cost of $125 plus $7.50 per shirt, so 7.5 N. My revenue then is going to be, what did I charge for the shirts? I charged $12 per shirt, so 12 N. So B part says, graph the total cost and revenue functions on the same set of axes. What does the point of intersection represent? So if I were to graph this, I'll put B over here. So going across the bottom here, this is my N, my number of shirts. And this is either going across the top here, I'm going to have my cost and my revenue. Okay, so if I do my CN function, I'll do that one in purple. What's that? 125 plus 7.5 N. So my y-intercept, because this is a linear equation, is going to be, if I say this is, whoops, that's supposed to be purple, 125, I would go from there, and then my slope is 7.5 over N, so I'd be going up 7.5 over 1, and then up another 7.5 over 1, up another 7.5, and over 1. So it would look something like this. And I'm just going to squish this down here a little bit because it's a little bit high in order for me to get in all my information. Okay, so if I pretend this is my 125 here, it's going to be my base cost, and then it's going to go up like that. So this is my CN. My RN then is going to be my revenue that I make. So if I sell 0 shirts, I make $0. So it's going to start here, and then it's going to go up in increments of 12 up, 1 over, 12 up, 1 over. So eventually it's going to go like this, and they're going to cross. So what does this intersection point mean? That's the point where I would break even. So where my costs and my revenue would equal, so I would basically be at $0 a profit, but then I would start to make money. So that is my break-even point. Okay, C says, profit P is the difference between revenue and cost. Write a function representing P in terms of N. So if my profit is the difference between my revenue and my cost, then my profit is going to be, oops, this is C, my profit is going to be my revenues that I make minus the cost that it was. Okay, so if I plug in my values here, this is going to be 12N minus 12 plus 7.5N. So this is going to be 12N minus 7.5N minus 12. So that is 4.5N. Where did I get my 12? That should have been 125, sorry. Minus 125. So D says, identify the domain of the total cost, revenue, and profit functions in the context of this problem. So my domain and this wants it based on cost, revenue, and profit. So for the cost, my domain, so what X values could I use for my costs? Well, because it's based on the number of shirts, it has to be greater than or equal to 0. I can't use less than that. My revenue, again, is based on the number of shirts I sell, and I can't sell anything less than 0 shirts. So that means my profit then is going to be not less than 0 shirts. Or not less than 0. Okay, now the last page here is just basically kind of a recap of what we're doing here with the function operations of doing addition and subtraction, and then looking at the graphs and doing some addition and subtraction with them. So if I'm given the function find f plus g of x and f minus g of x. So if fx is equal to 2x minus 1 and gx is equal to x plus 7, then what I want to do is I want to find f plus g of x, then I'm going to add 2x minus 7 plus x plus 3. So because I don't have a negative sign in between there and I'm not changing anything, then 2x plus x is 3x, minus 7 plus 3 is negative 4. If I do f minus g of x, oops, so this is going to be 2x minus 7 minus x plus 3. So 2x minus x is an x, negative 7 minus 3 is negative 10. So if fx is equal to x squared plus 1 and gx is equal to x squared plus 2, if I'm adding these functions, I have x squared plus 1 plus x squared plus 2x minus 1. So that is 2x squared plus 2x, and 1 minus 1 is just 0. If I'm subtracting these functions, I have x squared plus 1 minus x squared plus 2x minus 1. Whoops, my alignment is off here a little bit. So x squared minus x squared is 0, plus 1 minus a negative, so that's 1 plus 1, so that's a 2. And then I don't have an x on this side, but I will have a negative 2x on that side. So negative 2x, or 2 minus 2x, or I could write that as or negative 2x plus 2. Same thing. So what is then f plus g of 3? So what that means is I substitute a 3 into each one of those equations, or into each one of those x values. So there's two ways of doing this. I could go right back to my initial equations and do this, go f plus g of 3. So that equals 2 times 3 minus 7 plus 3 plus 3. And get my answer that way, which would be 2 times 3 is 6, minus 7 is negative 1, plus 3 is 2, plus 3 is 5. Or I could just simply go into my solved equation from up there. So this would just be 3 times 3 minus 4. So that would be 9 minus 4, which is 5. So you can see either way you'll get the same equation. So f minus g of 3 is going to be 3 minus 10, which is negative 7. Okay. Over on this side. F minus g of 1. So, I guess I did them both. F minus g of 1. Oh, I know what I did. I did the plus. I didn't have to do the plus. I could have just done the minus of this one. I'll do them for both of this one. So for this one, f minus g of x, if I'm using this equation here, f minus g of x. So f minus g of 1, if my equation was left with x minus 10, so that's going to be 1 minus 10, so that's negative 9. If I do it into this one, so f minus g of 1 is going to be 2 minus 2 times 1, which is 2 minus 2, so it's a 0. Okay, so here are the graphs of the functions. We're going to call this one here my f graph, and this one will be the g graph. So it says using the graphs determine f plus g of 0 and f minus g of 1. So the best way to do this is to break this up. So what this is saying is I want to do the f of 0 plus the g of 0. So remember, f of 0 means what is my y-coordinate when my x-coordinate was 0. So on the graph here, my f graph here, when x was 0, so when x is 0, my graph is down here at, and I think it should be a negative 6. 1, 2, 3, 4, 5, 6. No, it's a 7. So it's a negative 7. So f of 0 is equal to negative 7 plus g of 0. So when I'm 0 here, it's right here, which is at 1, 2, 3. So negative 7 plus 3 is negative 4. So f minus g of 1. So this is saying what is the function of 1 minus the g of 1. So when my x value was 1, so here is 1, my y value was over here at negative 5. Okay, so 1, negative 5, that was that coordinate there. When my g was a 1, so this is my g graph, here's 1, and that lines up with this one, so that is at 1, 2, 3, 4. So that's 5 minus 4, so that equals negative 9. Okay, so for this graph, f plus g of 0, so it's the same thing. This is saying what is the f of 0 plus the g of 0. So if this is my g graph and this is my f graph, at 0, that's right there, so my y value is equal to 1. On the g graph, when my g hits a 0, then it equals negative 1. So 1 minus negative 1 is 0. So f minus g, so that's the f of 1 minus the g of 1. So when my x, or my input value, was a 1, which is right here, my y value was, and we're going to take a little liberties here, and we're going to say that it's right there at the 1. The g value when x was 1 is right here, so it was a 0. So f minus g of 1 is equal to 1. Okay, Excuse me. So the next graph here is saying that they want you to find what would the graph of f plus g of x be, and what would the graph of f minus g of x be. So it says in the graph below is line f and g is the absolute value graph. So these are, f is a line, so it's a linear function, and the g is an absolute value graph. So if we want to do f plus g of x, and then f minus g of x. So this graph here, we're going to do f plus g of x. So what we have to remember is, what this is saying is, f plus g of x is the same as saying f of x plus g of x. So what you do then is you pick values. You pick x values, and then you're going to find out what is the y value for those. So if I were to choose, and I'm just going to scoot this down here a little bit, just ignore that, page 451, 1 to 8, that should be at the further down on the bottom of your page. So if I tried f of negative 4 plus g of negative 4. So f of negative 4, here is negative 4. So this is my f graph because that's the linear one, and this is my g graph because that's the absolute value graph. So at negative 4, my g value is here at, or not my g value, my y value is 1, 2, 3. So that is negative 3 plus, then if I do my y value on the g of 4, that's up here, which is at 1, 2, 3, 4, 5. So that is equal to, no, negative 2, it's just equal to 2. So that, then my new coordinate, if I want to call this my h of x graph, my h of negative 4 would be at 2. As a coordinate, that would be, negative 4, 2. So that point would be here, negative 4 and 1, 2. So if I were to do the next graph, negative 3. So when f of negative 3, and I'm just going to do a few of these, and then you're going to see a little bit of a pattern here as to what's happening. So negative 3, f of negative 3 is 0. G of negative 3 was up here at, and I think that's a 4. Better count 1, 2, 3, 4. So that means, whoops, that should be g of negative 3. That means that my h of negative 3 is equal to 4. So that coordinate is at negative 3 and 4. So negative 3 and 4 puts me here. So my next one, at negative 2. So f of negative 2 is up here, excuse me, at 1, 2, 3. So that's going to be 3 plus g of negative 2 also is there. So that's a 6. So that means that's going to be at the coordinate negative 2 and 6. 5 and let's see, where's that? 1, 2, 3, 4, 5, 6. So if you take a look here, you're going to notice a little bit of a pattern happening. Let's try one more just so that you can see where I'm at. Okay, so if I did negative 1. So at negative 1, my fx graph is here, which is at 1, 2, 3, 4, 5, 6. So that's going to be 6 plus my gx graph was down here at 2. So that's the coordinate -1 and 8. So -1 and 8. This is 6. It's just really hard to see these lines. That's why I'm being a little bit slower here. So you can see there's a little bit of a relationship happening here. So this one here, from this graph, I went as 2 above, and then I went to, what was this one? I was 4 above, and then at -2, I was 6 above. At -1, I was 8 above. And if you're looking at the relationship between the lines here, from here to here is 1, 2, 3, 4. From this point here to that point there is 1, 2, 3, 4. These two, it is 1, 2. This one here, it's 1 above. This one here then should be just 1 above. Or sorry, this one is 2 above. You just can't tell. This one was 2 above, this one is 1 above. And if you take a look at what that is, it's how far this line is above your x-axis. So it's how far your absolute value graph is above your x-axis. So if I tried the next one, if I tried it at 0 here, my f graph was up here at, I think that's a 9, and then my y graph is here at 1. 9 plus 1 is 10. So my point is right here. That is 1 away, even though it's hard to see on here. It's 1 away from my line because it's 1 away from that x-intercept. Right here. This point here was 1 away, so if you can see, the relationship is happening right here. That one. I shouldn't use that one because that one's not right on. Okay. So this one, from my f graph to my g graph, there's a difference of 4. Okay, so that means that from here, this graph here, I've got is at this point here, it's 2 above, then it's going to be 2 above from this point, so it'll be at 1, 2. This point here, it is 1, 2, 1, 2, 3 above, so then this one is going to be 1, 2, 3 above. Oh, my alignment is crazy. The next one was the 4. So if I take a look then, I won't be able to draw that one in there, but it's going to continue going up. So my graph is going like this and like that. So that's what f and g of x is going to look like. So what I'm doing then is I'm just subtracting my two y values in order to get my x values, or my new function values. So this one, my y value was up here at a 4, and if I subtract 4, take away, or sorry, it needs to go the other way because it's f minus g. So this is 2 take away 5, so I should be 3 up from my graph. Sorry, it's a plus, not, let me try that again. My f graph was at -3, my g graph was a 5, so if I add my y values together, that's how far above my x-intercept I need to be. So -3 plus 5 is 2, this is 2 above. So in this one here, this was at 0, this is at 4, 0 plus 4 is 4, so then my point should be 4 above the graph, and it is. My next one was where am I? -2 plus a -2, so it should be 0, and so on and so on. So it's adding them up, you get your intercepts. So let's try it for f minus g. Whoops. Oh. So f minus g of x is equal to, same thing saying the function of x minus the g of x, or the f of x minus the g of x. So if I look at the point -1, and we'll just do 1 point here. So f of -1 minus the g of -1. So at -1, where am I here? -1 on my, this again is the f graph, this is the g graph. Excuse me. At -1, where's my f value? It is, or my y value is at 1, 2, 3, 4, 5, 6. No, I guess it's 5. I can't count here very well. Oh, there it is. That's why there's 5. When my x value on the g graph was -1, so -1, my g value is at 2, and it's positive 2, so it's 5 minus 2, so that's going to be 3. So then that means that my point will be at -1 and 3. So -1 and 3 is right 1, 2, 3 right here. So what I did there is I just subtracted. I subtracted my two y values from each other, and then I plot that point. So if I just look at the graph here, then for my next one, if I did at, let's say at 0, so I'm at 9, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 take away 1 is 8. So then that means that my point is going to be at 8. So it'll be right there. So if I look at the 2 here on the y graph, if this is 11, right? 1, 2, 3, 4, 5. I'm just going to mark those a little more clearly. 6, 7, 8, 9, 10, 11. So that's at 12. So this will be 10 is here. So this is 12. 12 take away 1, 2 is 10. So then that means my point is going to be at 10. So 10 was right here. For this value, that's a 2. I have 1, 2, 3 is my g value. And up here, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 take away 3 is 12, so then that means my point will be at 12. So if this was 15, it's going to be right there. So they have to be, my x values are going to be exactly the same, but I'm going to subtract my y values. So over here at -2, my graph was, it's going to be -2 minus -2, so it's 0. So that means that this point is going to be at 0. For my -3, excuse me, my x is 0, or my f graph is 0. This one is at 1, 2, 3, 4. So 0 take away 4 is -4. So then that means this one's going to be here at 1, 2, 3, 4. So my graph, remember this is actually a tick mark, not a, is going to go like that and like that. So all I do is I subtract my y value for my f graph minus my y value for my g graph for this one. So for this graph on this side, it was adding, so I added my y value from my f graph to my y value from my g graph, and then I plot that above the x-axis. Same thing with this one. When I subtracted, I'm plotting it above that x-axis. So your questions were there, page 451, questions number 1 to 8.